So we're going to record a quick video lesson on notes on 7.1. Homework in 7.1 has to deal with the properties of triangles. We're going to slowly transition from geometry into trig, and then we're going to use that geometry and trig to solve triangles and find all missing sides and angles. So here's just a quick review of the content we covered in geometry. First of all, the three angles of a triangle have to have a sum of 180 degrees. The acute angles formed by a right triangle, so here if I have a right triangle, they're talking about specifically this angle we'll call A and this angle B. These two acute angles have to have a sum of 90 degrees. And when two angles have a sum of 90 degrees, they're called complementary angles. The longest side of a right triangle is the hypotenuse. And the two sides adjacent to the right angle are the legs of that right triangle. So when we talk about finding side lengths of a right triangle, automatically we go to our main man here, Pythagorean. And Pythagorean theorem states that if I take the hypotenuse squared, and that's equal to the leg squared plus the leg squared, most commonly known as c squared equals a squared plus b squared, or when I talk to my geometry kids, I always call it hypotenuse squared, or hype squared equals leg squared plus leg squared. We use this theorem to find missing side lengths of a right triangle. To find the missing side lengths of a side or an angle, we can also use our trig acronym, or also known as SOHCAHTOA. SOHCAHTOA, spelled S, and then usually it's OH. I like to stack the O and the H to represent my ratio as the opposite side of the triangle over the hypotenuse of the triangle. SOHCAHTOA. SOHCAHTOA. And remember, this is all coming from a right triangle where I have a given angle theta, and the sine is the opposite over hypotenuse, and cosine is adjacent over hypotenuse, and from tangent theta would be opposite over adjacent. When using right triangle trig, we can also look at the cofunction identities, which really allows me to look at these specific angles. If this is theta, then the angle that is also the acute angle of that right triangle is another angle we'll call theta, but we'll also subtract 90 degrees from that. So let's rewrite that a little bit so it's a little easier to see. So this angle is 90 degrees minus theta, or pi over 2 minus theta. And if I look at that co-angle of my right triangle, its opposite side is the adjacent side of theta. Its adjacent side is the opposite side of theta, and the hypotenuse stays the same. So when I talk about the sine of 56 degrees, if 56 is my theta, then its co-angle or cofunction angle is going to be 90 minus 56, which puts me over at 34 degrees. So the sine, which is opposite over hypotenuse, is the same thing as cosine, which is adjacent over hypotenuse. Pi over 3, when I take away that from pi over 2, which is also another way to write 90 degrees, I get pi over 6. So these are also co-function identity values. So now we're going to take all that geometry and trig, and we're going to apply that to solving right triangles. We're going to calculate, when we're solving a triangle, we're going to calculate all missing sides and angles. So here we're going to look at specific cases where we're trying to find the missing pieces. Remember, just as a note, as a quick reminder, we usually use A, B, and C as letters for angles, where C is usually the right angle, and the lengths of the sides opposite of those angles are lowercase of the same letter. So here we have a right triangle where the one angle B, we'll say it's 65 degrees, and we have angle A, we have side A, which is opposite of angle A. So this would be angle A, and then we'll call this side A. A is 14, and then obviously that makes my right angle, and my third angle C makes this little c. So if we're solving a right triangle, we want to make sure we find all those missing sides and angles, and we do not use rounded off version to compute missing sides or angles, so we always want to use the most exact answer possible. Angle A is the other angle, the other acute angle that's associated with 65. So to find angle A, all we do is take away 65 from 90. And when I do that subtraction, I end up with 25 degrees. So this angle is 25 degrees. That's the measure of angle A. B was given to me at 65 degrees. And angle C, we know, is 90 degrees because it's my right angle. Once we find the angles, we're going to use a little SOHCAHTOA or right triangle trig to find the missing pieces. Given that I know that B is 65 degrees, I can go ahead and use the opposite side, which is B, and the adjacent side, which is A, and we can use opposite of adjacent, which is tangent. So the tangent of 65 degrees is equal to the opposite side, which is B, over the adjacent side, 14. Do a little cross multiplying. I end up with B is equal to 14 times the tangent of 65 degrees. And I can go jump in my calculator and I can put that in. Make sure that since we're talking about an angle in degrees, I can keep it in degree mode or radian mode. Here I'm in radian mode, so if I hit sec and quit, I have to make sure when I do this product, which is 14 times the tangent of 65, I want to make sure that when I take that product, I do 14 times the tangent of 65, but I want to put the degree symbol in there since it's a second angle, 1, since I'm in radian mode. This will give me my answer as if that were in degrees. So this third side here for B is going to be 30.002. We're going to round 3 decimal places because we want to make sure that we always round 3 if that's what we're given. So side B, we'll label that as 30.023. We're given side A, which was 14, and side C, which is opposite of the right angle. We can find that using right triangle trig as well, or we can use Pythagorean theorem. I want to try to be as exact as possible. So here, since I want to find side C, that's my hypotenuse of my right triangle. So again, if I use, for example, cosine, which is adjacent over hypotenuse, so the cosine 65 degrees would be equal to adjacent 14 over hypotenuse C. Here, when I do cross multiplying, and then I divide by the cosine of 65, I end up with C being equal to 14 divided by the cosine of 65 degrees. So in my calculator, I do that exact same thing now. 14 divided by the cosine. And let's just say I want to keep that in degree mode. I can always go second mode and turn my calculator quit mode. I turn this into degrees. And then I can go ahead 14 divided by the cosine of 65. That means my angle is in degree mode. And that's going to give me 33 point, my calculator, 33.127. Alright, so go ahead now and don't be freaked out here by the different letters. Angles A, B, and C could also be rewritten as Greek letters, alpha, beta, and gamma. But go ahead now and do the same process to solve this right triangle. Go ahead and pause the video and try it on your own, and then follow along as I fill in the work as well. We have a right triangle. Here we'll call this beta, we'll call this alpha. Here I know alpha is 40 degrees. Here I know side B is 3. We want to find the rest of the information. This is 40. This is 90. So this is going to be 50 degrees. And side B is 3. Using a little right triangle trig, we can go ahead and use the cosine of 40 degrees is equal to opposite, or adjacent, over hypotenuse, which is C. Cross multiply and divide, C is equal to 3 divided by the cosine of 40 degrees. In my calculator, I do 3 divided by the cosine of 40 degrees. It's going to give me 3.916 for C. 3.916. Alpha, I'm trying to use alpha here, and I want to find the opposite side and use sine 40 degrees. Or I could have used 50 degrees, depends on which angle you want to use. It doesn't really matter. Opposite is A over hypotenuse. Again, I don't want to use sine if possible because this is an approximated value. So actually, rather than using sine, let's use the tangent of 40 degrees. And we'll do opposite A over adjacent 3. 3, the adjacent side, is an exact value rather than using an approximated value. It's just going to give my answer a more correct response. A is equal to 3 times the tangent of 40. And looking at my notes or looking at my calculator, I get that third side to be 2.517. Alright? Again, always remembering here, as you're looking at the answers, your largest angle is going to be opposite of your largest side, medium angle, medium side, and smallest angle, smallest side. That property of triangle inequality is always true, and it allows you to quickly check your answers to make sure you've plugged them in correctly. Now that we've kind of talked about how solving right triangles, we can go through that. We have this thing called angle of elevation, angle of depression. It's all denoting the angle that's formed by the horizontal and the upward location of the object. So angle of elevation, here's my line of sight. I'm looking up at an object, so that's my angle. Whereas angle of depression is denoting the horizontal from the downward location of the object. So again, line of sight, looking down at an object this way. So if here, for example, if I'm looking at a bird in a tree, and the bird's up here, and he's looking down at an object like a, for example, like a worm, here my horizontal line of sight is going to go in this direction. Okay? However, the bird's horizontal line of sight is very different from its angled sight when it's looking at the worm down here. Now the worm, on the other hand, he's got an angle of elevation. Since he's looking up at the bird, his line of sight is the same, but his horizontal is down here on the ground. So again, if I look at these dashed lines, these two horizontal lines are parallel to each other. So they actually form, by this transversal, two angles that are alternate interior of each other. And since they're alternate interior of parallel lines, they have to be congruent to each other. This would be my angle of depression. Okay, right here. And this would be my angle of elevation. Now, angle of depression, angle of elevation, since they are both alternate interior angles of two parallel lines, I know they have to be congruent to each other. So the angle of elevation is congruent to the angle of depression. And those are just two little quick abbreviations of that. You guys can see how those would be equivalent to each other. So let's look at our first example here. We have a person standing on top of a 40-foot tall building. It cites a friend on the ground. So the important information that we want to pull out here is that we have a person standing at the top of the building, and that building is 40 feet tall. So looking at my picture here, this building is 40 feet in the air. A person is standing at the top, and that person sees a friend down on the ground, say right here. The angle of depression is the angle formed from that person at the top. So that person looks out horizontally, and they're looking in that direction. However, they're looking at their friend down here at the ground. And that angle, which is formed by those two lines of sight, is my angle of depression. Now we just said that that angle of depression is equivalent to its alternate interior angle, which is also opposite of the angle of elevation. So here, when I look at this picture, and this person, these two lines are parallel to each other, meaning that this angle is 52 degrees, which means this angle is also 52 degrees, and it's also on the interior of my triangle. I also could find the adjacent angle to the angle of depression, which would be complementary, since that angle is a right angle, so you could always subtract 52 from 90 to get that angle adjacent. We know this is a right triangle, because hopefully it's a structurally sound building. So if we're trying to find then the angle of depression is 52 degrees, we've already labeled that. We want to know how far is the friend from the base of the building. So from the base of the building to his friend, we want to know that distance. So we're trying to find that value of x. Since we're trying to find the adjacent side and the opposite side is given to me to the angle 52, I'm going to use the tangent of 52 degrees, and that's going to be equal to the opposite side, which is 40 feet over x feet that I'm trying to solve. A little cross multiplying and dividing, x is going to be equal to 40 divided by the tangent 52 degrees. X is going to be equal to, using my calculator to approximate that value, it's going to be equal to 31.251 feet. That's how far away our friend is from the building. Looking at number 5 now, at a point 100 feet from the base of a building, the angle of elevation to the bottom of the smokestack is 37 degrees. So let's slow down here. Bottom of the smokestack, 37 degree angle, at a point 100 feet from the base of the building. So let's quickly here just draw a building. Here's my structure. On the top of that structure we have a smokestack that's coming off of it. So we'll put a smokestack on top of that building. That's got some smoke coming out of it. I'm not worried about that so much. And now we have two different angles from a location that's 100 feet away from the base of that building. So as I walk away 100 feet from the base, okay, I have an angle of elevation from the bottom, from the location 100 feet away to this angle. So here, from this point, from the base of the smokestack, I have an angle 37 degrees. Now, that angle creates a triangle, just like that, where I'm trying to find the height of the building. The other measurement they give me is they tell me that the height of the angle of elevation to the top of the smokestack is 42 degrees. So here, when I draw my picture, from that same spot, the angle of elevation from the horizontal to the top of the smokestack is going to form an angle that is 42 degrees. So this angle is 42 degrees. He's part of this triangle right here. So ultimately what I'm trying to find is I'm trying to find the height of just the smokestack alone, which really is, if I look at it, is this height right here. And that height is going to be equal to the height of the entire smokestack and building, minus the height of the building. So if I can find those two opposite sides of those angles, then I can take their difference and find the height of that smokestack. So when I look at the red triangle, we know this distance is 100 feet. If I'm trying to find the height of the building and the height of the building and the smokestack, I'm going to go ahead and look at my two triangles, and I'm going to use tangent to find those missing pieces. The red triangle, I'm going to use the tangent of 37 degrees, and he's going to be equal to the height of the building over the 100 feet that I have right there. The blue triangle has a tangent of 42 degrees because I'm going to use opposite and adjacent. So here I'm going to have the height of the building and smokestack, the SB, all over 100. So we're just going to solve for the heights of the two buildings with the smokestack and without. Here, if I simplify this expression by doing a little cross multiplication, I end up with this being equal to 100 times the tangent of 37 degrees, and the height of the building and the smokestack together is equal to 100 times the tangent of 42 degrees. Since those are the two values, I can then go ahead and subtract them. So x is really equal to the difference of this, 100 tangent of 42 degrees minus 100 times the tangent of 37 degrees. When I plug that all into my calculator and I simplify, I get a value of x, which is equal to 14.685 feet. So a lot of these problems, you're going to have to draw a picture, you're going to have to identify what you're trying to find and label the given information, and use some type of right triangle trig to find the missing piece of information. Go ahead and try number 6 on your own. The answer key is posted. You're going to have to try to figure out the altitude. You can use the altitude to figure out the angle of ascent, how fast that plane is climbing in terms of its angle. So go ahead and try that, and then check with the completed note key online as well.